Welcome back students to the second part of the chapter Matter. We will have a quick recap what we have studied in the earlier video. We have studied the definition of matter. Anything which has mass and takes up space is known as matter. Constituents of matter. Matter is composed of tiny particles or molecules. Properties of the particles, like the particles have kinetic energy. They move about from their mean position in case of liquids and gases, but they are held tightly and cannot move. They can only vibrate in case of solids. The states of matter are solids, liquids, gases, plasma and boson particles. But we will study only about solids, liquids and gases, as these two things are out of scope. Next, molecular model of the states of matter and their properties. Now in this video, we are going to learn the details about the change of state of matter, how the matter changes from one state to another. So we will learn about in details about the evaporation, condensation, sublimation, freezing, etc. Explanation of the change of states of matter in molecular level, how this change is happening in the molecular level, right? Evaporation, boiling, sublimation and difference between them. So let's get started. Change of state of matter. The definition is the process of change from one state to another state, either by absorption or rejection of heat at constant temperature, is known as change of state. Now this absorption or rejection of heat may be also termed as energy. It is a physical process. This has to be noted. This is important. This is a physical process because it involves change in molecular structure without altering chemical composition. For example, if we put liquid water in the deep freezer, after some time we will see that it has changed to ice. So the liquid water is composed of hydrogen and oxygen. The molecular formula is H2O. After freezing to ice, the molecular composition remains the same. Now if we convert it into steam water, if we boil it down and convert to steam, then also the molecular composition remains the same, right? So it's a physical process and it's completely reversible. If we put the ice outside for a long time, we will see that it again converts to liquid water. So it's reversible. Change of solid to liquid, which is also known as melting or fusion. Now let us study this in the molecular level. Earlier we have known and also you know that solid molecules or particles are held very tightly. They cannot move about freely. That is the reason why they are solids. The intermolecular space is very less. Low intermolecular space and high intermolecular force of attraction. Right? So when we are providing a heat means energy. Heat means energy. We are providing the kinetic energy of these molecules or particles increases. They start moving more briskly, and a time comes when the kinetic energy is so much that they break away the intermolecular force of attraction and becomes a fluid. They become mobile and they change to liquid. So we are just adding energy, and a time comes. What is that point? That is point known as melting point or fusion point. It's a For pure substances it is fixed. We will read about the properties in a later slides. The reverse thing happens while freezing. In case of liquid, the intermolecular space is high. The intermolecular space is high, so the particles can move about freely. Okay. Now, if we are cooling it, mind it, there is nothing called cooling. We are taking away the heat. We are taking away the energy or heat. We are Another term is extracting the energy, taking out the energy. Cooling means taking out the energy. So the kinetic energy becomes lesser, and time comes when they again stick together. They come together. Their kinetic energy becomes so low that they just can vibrate about their mean position. They cannot move about freely. So they becomes again solid. So this is the change from liquid state to solid state. This change is known as freezing. Now let's come to change from liquid to gas, which is known as vaporization or boiling. Here also, at the molecular level, the liquid particles have large intermolecular space between them. They have kinetic energy, so they are moving about freely. They are fluids. Now when we apply heat or energy, the intermolecular spaces increases, and we know that gases have the maximum intermolecular spaces and their kinetic energy is the highest. So these these are also fluids. Fluids means which can flow. Liquids can flow, gases can flow, but these are liquid form. This is the gas form. So the liquids gets converted to gas. Again the reverse thing occurs. The gases have high intermolecular space between them, low force of attraction between the particles. They have high kinetic energy. When we are cooling it or extracting heat from it, taking away the heat, again the kinetic energy becomes lesser and they come closer together and they get converted to liquid. Now if we continue extracting the heat, cooling it, we will see that it again converts to solid form, right? That as just we have discussed earlier. Now another phenomena is there which is known as sublimation. In this case, the solid changes directly to gas. There is no liquid state that comes to effect, or gas to solid. like vice versa. This is known as sublimation. We all have seen like camphor, naphthalene balls, dry ice. Dry ice is solid carbon dioxide which has been solidified. It is very cold and it is used in cooling, to cool things in industrial purpose also. Okay. So if you see that if you heat camphor, you will see that it does not melt but changes to gas directly. Naphthalene also, if you keep naphthalene balls in the cupboard, you will see that it's the size gets reduced but you won't be seeing any liquid form of naphthalene. Why the size reduces? It gets converted to its gaseous state, it sublimes. The same is dry ice. The melting point of dry ice is minus 78.5 degrees centigrade. It's extremely cold, right? Minus 78.5 degrees centigrade. So whenever we have take dry ice, so whenever the if we keep it at room temperature, since the room temperature is of course more than minus 78.5 degrees centigrade, you will see that fumes are rising. It leads to a cloud of gases. So it does not come to the liquid state but changes directly from the solid to the gaseous state. Okay. Now let's study about the properties of the changes one by one. Melting, the definition we have studied, the change from solid state to liquid state on heating at fixed temperature. Solid changes to liquid, this is the first criteria of course. Absorption of heat. So liquid, solid changes to liquid when we apply heat to it. We have just learned about the work of this heat, the necessity of this heat, because that heat is required to increase the kinetic energy. This heat is utilized in increasing the kinetic energy of the molecules. Temperature remains constant during the change. This is a very important aspect. Temperature remains constant. You can do a experiment if you have the apparatus, of course. If we take a glass of water and just keep it in the freezer unit, and we will just measure that, after some time we will see that a very thin layer of ice has formed on the top layer, but here the inside remains in the liquid state. Now if we dip a thermometer, the clinical thermometer won't do, we have to use a laboratory thermometer. If we will see that the reading is 0 degree centigrade. Now after we let it freeze, the total water freezes after some time. Then if we measure the temperature of the ice, we will see that it is again 0 degree centigrade. Right? So the temperature does not change while changing because the heat that we are providing, it is utilized in increasing the kinetic energy of the molecule and no temperature occurs. So this is known as latent heat of fusion. So we will be studying it at a later class. Right? Sorry. Melting point of pure substances remains constant. If it is a pure substance, if you take distilled water, you will see that wherever you go, what sample you take, the freezing or melting point of pure ice made from pure water is always 0 degree centigrade. Is always 0 degree centigrade. Like if you take a metal, uh, for example aluminium, the melting point of aluminium is 660.3 degree centigrade. So it's a very high temperature. We cannot do it at our home. It is done, it can be done only industrially. But aluminium, this temperature, this melting point is always constant for pure aluminium. For NaCl, which the common salt that we use at our home, if it is pure, so it will be 101 degree centigrade. If you can heat the salt to 801 degree centigrade, you will see that it melts. So now let's continue. Freezing. Freezing is the opposite of melting. Freezing means what we do if we keep some water in the liquid water in the freezer unit, so we will see that it has changed to ice. That is known as freezing. The change from liquid state to solid on removal of excess of heat at fixed temperature. Again, the removal of heat. Cooling is nothing but removal of heat. Liquid changes to solid. Of course, this is the definition. Release of heat. While freezing, the substance releases heat. Why it releases it? Because in the liquid state it had kinetic energy between them. Now when it changes to the solid state, it should lose that kinetic energy. That energy is given out in the form of heat. Now we don't see heat coming out because we are cooling it, we are extracting the heat from it. Okay. Temperature remains constant during change, as we have known earlier. This is the latent heat of fusion. The temperature change is given out in the there is no change in temperature. The heat that we are extracting is from due to the change in kinetic energy. Freezing point of pure substances remain constant. Again, if we take pure water and freeze it, it will always be 0 degree centigrade. Vaporization, the change from liquid state to gas state on heating at fixed temperature. Liquid changes to gas, there is always absorption of heat. That means we are adding heat to it. Again, as I have said before, adding heat means we are increasing the kinetic energy. Liquid has intermolecular space between them, we are just increasing the kinetic energy so they become gas. So that heat we have to supply. Temperature remains constant during change. This is the same phenomena. Whenever if we take water at boiling point, when it is just boiling, the boiling point of water is 0 degrees, 100 degrees centigrade. But if we uh, measure the temperature of the steam, just the steam that has formed, we will see that it is again 100 degrees centigrade. So the temperature, this is called latent heat. Just I am telling the term latent heat of vaporization. So why cannot we see any temperature change? Because this heat that has been provided is taken away by the molecules in increasing the kinetic energy. So the temperature change does not occur, we cannot see. Right? Boiling point of pure substances remain constant. Again, for example, pure water, the boiling point is 100 degrees centigrade. Wherever we go, whatever sample we take from wherever, so the boiling point of pure water will remain like this. If we take liquid nitrogen, okay, so it is used in many research purpose in industries, in medical fields, liquid nitrogen, the boiling point is minus 195.8 degrees centigrade. It's extremely low temperature, so we cannot have it in our home. But the boiling point is 100 minus 195.8 degrees centigrade. It will boil at this temperature. Now, the opposite of evaporation or boiling is condensation. We will just study it quickly. The change from gaseous state to liquid on cooling at fixed temperature. Gas changes to gas changes to liquid. Release of heat. Again, why there is release of heat? Because the gases has high kinetic energy. So we have to take away the heat to bring it to liquid state. Temperature remains constant during the change. I'm giving a very small example. You should not try this at home, but sometimes accidentally when water is boiling, and if we put our hands over it here, we'll see that that steam gives a extremely burning sensation. That is because steam contains a very high energy in them, and whenever it touches our hand, it falls on our hand, it gives a extremely burning sensation. Now the last change that we are studying is sublimation, the change from solid state to gas on heating or vice versa at fixed temperature. We have already studied it at the molecular level, why it happens. Solid changes to gas or vice versa, absorption or release of heat, temperature remains constant during change. What is happening? If we take solid, again solids are having low intermolecular space between them, they are packed tightly. Whenever we are heating, for example, this is ammonia, NH4. Now if we heat it, sorry, NH4Cl, ammonium chloride. So if we heat it, the kinetic energy becomes more, but it does not come to the liquid state. This is the property. Another example is, as I have said before, solid carbon dioxide, solidified carbon dioxide. It is also known as dry ice. If we keep it, it will get converted to gas carbon dioxide without coming to the liquid state. This is known as sublimation. Evaporation or vaporization, the change from liquid state to gas on heating at fixed temperature. Solid changes to gas or vice versa. Absorption or release of heat. Temperature remains constant during the change. Sorry, this is not solid, this is liquid. Liquid changes to gas or vice versa. Right? The evaporation, we can see the water cycle, because of which the rain happens, because of which there is life on earth. It all depends on this evaporation. The water evaporates from the ocean surface, oceans and lakes surface, and then again it forms clouds and brings rain. We have all studied it in earlier classes also. Temperature remains the same during change, as we have seen it. Right? We will give it a quick skip. Now let us study, there is a difference between evaporation and vaporization or boiling. Evaporation means what? If water falls on the floor, for example, after some time you will see that the water is no more there because it has evaporated, but you haven't added any heat or you haven't heated it, right? So why does it vanishes? Because of evaporation. Either after mopping the floor, you have seen that after mopping the floor we turn on the fan, so the water evaporates from the floor and after some time it vanishes. But boiling, when we are making tea or cooking food, when we are boiling water, you will see that the water is boiling briskly. So we will study about the difference here. So the definition is process of liquid molecules escaping from the surface into the surrounding air at temperatures below the boiling point. Right? So evaporation happens all the time at room temperature also. If we Another very good example is uh, of drying of clothes. If we put wet clothes after washing in the air or in the sun, we see that it dries. So where has the water gone? The water has evaporated and it occurs at normal room temperature. Vaporization is the process of converting a liquid into vapor through the bulk of the liquid. Temperature range occurs at, as just we have discussed before, it occurs below the boiling point, and boiling or vaporization occurs at the boiling point. For water, for example, water at it is 100 degrees centigrade. In order to boil a liquid, we have to bring the temperature to the boiling point of that liquid. Location occurs only at the surface of the liquid. This is important. If you take water in a saucer or any container, the evaporation occurs only from the surface. There is also a molecular phenomenon, means the molecules which are on the top level or the surface, they escape after gaining the adequate kinetic energy. But the molecules or the particles which are inside, which are in the bulk, they are not getting affected. They don't get away. Eventually, when this top layer evaporates, then the layer which is underneath it, it becomes the top level and the process continues. Occurs throughout the bulk of the liquid. Whenever we are boiling anything, the boiling or the change from liquid to gaseous state occurs from the throughout the liquid. Rate vaporization is slow. You will see that when we dry clothes, the drying takes a lot of time, but boiling is very fast. Energy requirement requires a less energy compared to vaporization, requires more energy because we have to provide heat externally. And but vaporization, it occurs at the room temperature, so the energy requirement is less. Process spontaneous process influenced by factors such as temperature. We will study it in the next slide. The factors which affect evaporation, but these factors do not affect vaporization or boiling. Examples can be drying of clothes, uh, drying of puddles, boiling of water to produce steam, heating up pot of water on a stove. Now let us study about the factors that affect the rate of evaporation. The factors are, first of all, temperature. If we rise the temperature, increases the rate of evaporation increases with rise in temperature. Rise in temperature. If we increase the temperature, the evaporation will occur faster. Then is the wind speed. It also that increases with increase in wind speed. We have seen that in rainy seasons particularly. So if we want to dry our clothes, so in the rainy season the clothes do not dry quickly, so we put it under the fan. Or if we take anything, we mop the floor is wet, if we put on the fan, that is we are increasing the wind, so the water evaporates quickly. Surface area, if we increase the surface area, one experiment you can do, if you take some water in a cup or a glass and you take the same amount of water in a saucer, you can put a very small amount so it will occur quickly, and you keep it for some time, you will see that the water in the saucer has evaporated, it has vanished, but water remains in the cup because the surface area is smaller in that of cup, but it is high, more in case of the saucer or the plate. Next comes humidity. Humidity has a reverse effect. More humidity, low rate of evaporation. Okay. Again, we have seen experienced this phenomenon in the rainy season, in the summer time or the winter time. Other than the rainy season, the clothes dry very quickly. But in the rainy season, we find it very difficult for the clothes to dry. This is because there is, what is humidity? Humidity means presence of water vapor. So when there is already lots of water vapor present in the surrounding, so the water particles which is present inside the clothes, they find it difficulty to go out, to escape. That is the reason why the rate of evaporation becomes very low. Okay, so this was all about the matter. If you have any difficulty or you need any explanation in a particular field, so please comment me, and I will be more than happy to help you. And please subscribe the channel to keep me motivated to post more videos, and I will give this presentation in the form of PDF in the description, so if you can need it or refer to it, you can do it. Okay, so all the best. Bye.